everyone. I'll try to speak loudly so you can hear me. And feel free to stop me anytime and ask questions. I was coming to talk through virtualization for central office and how we virtualize access networks. And then I realized I had about half an hour to do so. He's a lot of my time. So what I wanted to do is, how many people here have actually operated in central office or worked in central office? Perfect. Okay, so there's some people that know what I'm talking about, probably better than I only work there very rarely. But I just want to go through what is a central office as a starting point. So a little bit of a guided tour then of central office. And we'll look at pictures. To start with, this is what the central office was when we started telecommunications. It was a bunch of people coming into a room and there were ladies there punching you in and taking up various people across connections. Moving on in time, we got a little bit more intuitive and we automated this. And then we had these machines. You can clack. I don't know if anyone knows or they've ever heard the sound. You look up the sound of the central office on the internet and try and hear it. It was just a thunderous roar across the net going clack. It was all mechanical. There was big stacks, cables coming in, basically little switches spinning around, and connecting phone calls together. Moving on in the world, we go digital, and then we start connecting together with cables, and then you end up in a situation where you have hundreds of thousands of these tiny little cables coming into the office room somewhere. And then you have very simple computers at the front end connecting up and doing what the digital devices used to do. This is when telecommunications became affordable to people. We all of a sudden could scale these things up, and you had massive buildings in the middle of cities that had thousands and thousands of cables coming in. And then we move into a digital age, and we move into being able to multiplex traffic. We're able to put a lot more onto one cable. And the central office became even more exciting and started to look something like this. And this is how a central office looks for the most part, a smaller one today. You still get large central offices in major metropolitan areas. But for the most part, the access pieces of the central offices can look something like this. It's a relatively small building, and it has a bunch of equipment. And today, if you walk into a central office, it's going to look something like this. There's a guy, he's looking at a bunch of different boxes, and each of these boxes today, it comes with connectivity, whatever the physical connection that has to come in, comes into it. It has an operating system generally built by whoever built the box. Based on Linux for the most part today, it's still proprietary, embedded. The hardware is built for purpose, the software is built for purpose, and you basically wrap these things and stack them along and you scale up how many people you actually have terminating into a central office. So today's optical connections is going to be copper connections coming in, depending on where the central office is. So we more or less have today this central office. Back in the 80s, I think it was, we started to call these things data centers because they started to deal with computers, connectivity computers. But today they're a little bit complicated still, and it's too complicated. Each of these boxes has an interface that someone has to know how it works. Someone has to be able to interact with, someone has to be able to manage and control them. I may have a bunch of these boxes from Ericsson, a bunch from Huawei, a bunch of Cisco, all doing the same thing, all different management interfaces. You talk to some large telecommunications operators, and they literally have 400 different management interfaces they have to work with, and they have thousands of people who are specialists on how to work with one of these boxes. So they have problems trying to actually manage their costs, because in order for us to make phone calls, they have to maintain thousands of people to manage this. And those people, for the most part, we don't know how to plug things in. That's another set of people, So the central office today is a complicated place. It has a lot of purpose-built equipment that serves the telecommunications industry. What we want a central office to look like is this. It should be beautiful. It should be simple. It should be the place that Tron wants to hang out in, with a lot of blue lights and not deal with. So really what we're trying to do is remove the speciality, get rid of the demons of the current, which is the vertically integrated solution, and move towards beautiful data centers with beautiful hardware and consistent platforms and management interfaces. And I'm running these different things and applications on top of that. So that's the target, that's where we want to go. And central office, tour and pictures, that's more or less it. 5 minutes, now we're all on the same page, we know what we're talking about, and we know where we're going to head. Then we get to technology, I guess. From a technology perspective, I have my central office on the far side. And the central office is containing some of these boxes, the provider edge router, PNG, the enemy, signal gateway, aggregated web, or connecting your house up, connecting your phone up. Yep.
Sorry, would it be possible to switch off the first slide? Because it's very difficult to see.
Main. I'll let Charles try and sort that one out. My pieces are not coming up. Okay. But in general, you'll have in your house a DSL modem, something that connects up to this central office and something that provides Wi-Fi. You may have a phone modem which connects to an optical cable coming into your house. Generally, DSL is running on copper. It looks like a phone connection is put into the wall. PON is an optical connection goes to the wall. Or maybe you're just using the 4G network and you're terminating radio in your house using Wi-Fi out there. Lots of different ways of getting access, essentially these days, to the internet. That's what we provide access to, is how the internet gets to your house. There is a multi-service network that connects you up. The multi-service network is interesting. There is a RAN network. This is the radio access network. It's built for the purpose to connect the towers up so that they can speak to your phones and devices. That's separate, for the most part, to the DSL network that connects your home up, connects your Wi-Fi network, which again is usually at least logically separate from the PON network that may be terminated from something like that. And each network uses different technologies, each network uses different calculations, each network generally steers traffic in a slightly different way, and each network then terminates into the data center in a different way. So we still don't have a consistent way of getting that information into the central office where these boxes are, which is why they don't have their own plugs and they don't have their own ways of getting stuff done. So, and the central office still looks like this. We're still connecting up to these virtual boxes. But how can we move forward then? The idea, and what we talk about when we talk about virtualizing the access and virtualizing the central office, is to get rid of the obstacles that we have in place today. Okay. We want to standardize the infrastructure. We want it to consist of data centers. We want the same compute. We don't have a microphone. This is. Okay. We get a microphone. Okay. I will talk to this slide. Anyway, we want standardized infrastructure. And standardized infrastructure is the compute, right? That's how we build data centers. We know the data centers. A bunch of boxes connected up to fabric on the back end. Usually electric, maybe also your. And that's a data center. Then we have the network. How does the network come in? Do we have proper cables coming in? Do they also come in? How is it being managed? How is it isolated, or what are the different protocols or calculations that come in? And we also want to enable easy software deployment. So if we have a common hardware and we have hopefully a simple network, how then can we build the software that runs on these things? Remembering, if we go back to the slide, these boxes usually are 5 or 6 years in the making. A lot of engineering goes into this. It's not just put it together and it works. There is software built for purpose. It's optimized to run at the best that it can possibly run. There is a lot of effort put into the engineering and deployment of these things. The challenge is, so I'm an operator and I buy this box and I can manage 100 million users and the throughput is 400 gigabits or whatever it's going to be. What I don't want to happen is I don't want that box to fail. So what I'm going to do is I'm going to run it at around that 40% capacity. Because in peak hour, maybe I need to go up to 80% of the capacity, and if I go over 80% of the capacity, the software starts to fail. So generally what's happening is these things are sitting there running half at best of their capacity. And this is a problem because they don't ramp down, right? If they're running at half their capacity, they're still burning and ticking over at full capacity. They're just ticking over idle processing. So what we want to do is get the software out there in a more flexible manner, like Nanolet. So we want to be able to put software and it should scale according to need. And we're not using something that should be able to be moved away so something else will take place. So, sorry, it's never going to talk about open source. Yeah, all right, I'll get there. Unfortunately, the central office it's a physical thing, right? And what we want to do is figure out how to get open source into this physical thing. So understanding, I guess, where we're trying to go is really important. when we talk about the future of the central office, we talk about a couple of things. We talk about the fine aggregation network. In other words, pure optical out as far as we can go. Fiber to the something. Fiber to the closest point to the consumer that we can get. It's generally the way we do this. So fiber will go straight out to the radio base stations. It can go out to on devices, and it can go out to potential distribution points where you can't get fiber all the way out, or it's too expensive to get fiber all the way out. But there will be some sort of fine aggregation. It will be standard. It will be wider again. But that doesn't really solve the problem, because I still have a network out here and I still have a data center here, and then I need to be able to bridge these two things. So what's happening now is that's something called VLT. I think these slides are going to be put up, and there is a link in that VLT to a document with AT&T that you can go to the few projects that now are starting to talk about. And what that talks about is essentially creating a new device that terminates OT into the data center. So this connects, it's hard to really see it, but there is a small sequence of connections over here that provides you with essentially small OT connectors into that box, and you have 48 Ethernet on the backside. So what you're doing is you're hooking your optical network going out to the edge directly into the fabric of the data center. What that means is that all of a sudden I need to be aware of the fabric of the data center if I'm going to be able to manage the access side of the network. I can't just use XLAN and encapsulation network the way the two works. That's not what's going to happen. So when we start to talk about virtualizing CO, we start to talk about terminating the OLT actually into the data center itself, not via a gateway point or something. Then we start to look at different types of data center. What we do want to have in the different type of data center is a common virtualization solution. We don't want a new software stack that we have to use in the CO. That's what we're trying to move away from. So we look at what do data centers run today with OpenStack, with Linux, and then we see how does this fit in this environment, what's missing, in order that I can run a virtual provider or a virtual entity or a virtual and then terminate essentially optical connections directly from wherever into the virtual function. Okay. So what does common virtualization software look like? And here I'm going to plug a project I worked with, which is called OpenNV, Open Platform NV. For those that aren't aware of it, it's 2.5 years old maybe. It essentially integrates carrier technologies, open source carrier technologies into a stack. So you can go with an OpenStack and that works fine. You can go with an OpenNV stack and that will come with a daylight built-in, maybe FPIO is reporting, USFC there, you can do peering endpoints. There's a number of new technologies that are being brought in by this stack that allow us then to deploy into types of environments like the central office. So I'll take 3-4 minutes to talk about OpenNV before I move on, because it's kind of important. OpenNV perspective, one of the focuses of OpenNV is integration. What we do is we try and bring in new components into an OpenStack environment. We try and make sure they run on Red Hat or SUSE Linux. We try and make sure that we're not specializing. We try and ensure that we have consistency and cohesivity across the stack. We use Open Daylight. There's a bunch of projects in Open Daylight that come in later. And then the data plane, you could be running on an ARM data center, or you could be running on an Intel x86 data center, an x86 data center. I don't like to say that. So you can run ODP, or you can run FPIO, or you can run ODS, depending on what you want to achieve and on what infrastructure you're running. And then we run a bunch of tests on that. So one of the things that OpenNV does is around that 8 hours of testing and any deployment. So it's a full CI/CD solution. It will deploy a data center on demand, and then it will run a bunch of tests from Open Daylight, from OpenStack. Locally, it will run virtual IMS systems on it, and then essentially come out with the results of whether the stack service is more than But that's not quite where we need to be yet. Some of the key things that are coming out in virtual CO is what VLT is. Cornerstone will change the fabric that we're actually running the data center on. So VLT is the key piece of where we need to go. We require fabric to access connectivity control. You can't just plug things in and hope that they work. You need to be able to actually isolate and identify the types of traffic you need. So we do require fabric to access point for you. That's SDN. It's not SDN that you know it neutron. It's more SDN that you know it bunch of daylight projects that could provide that service, or OS projects that could provide that service, or an orchestration system like a Remote. It also requires VM, container, and maybe software lifecycle management. You need to be able to deploy directly on workloads. So a couple of areas that are in the open source community which are starting to address is ONOS has spawned a project called Core. And Core is the central office reimagined as a data center. And they are focusing exclusively on this problem, bringing VLT from the project. ONOS and Core focus mostly on open-flow-based control, so they assume you have an open flow into a network. It's very much a greenfield approach to how I would virtualize data center. We have Open Daylight. Open Daylight has network, it has the Courier KAS integration work, and then it has the virtual CO project. These three things are kind of important. First, the network project allows you to connect OpenStack and provide you the full network switch. Courier KAS stuff allows you to connect Kubernetes and allows you to connect between the VMs and containers and the bare workload. So a lot of the work going on there to create that networking solution, common networking solution between containers, VMs, and bare metal workloads is a key part to extending that network capability. And then the virtual CO, which is the fabric management and extending it out into the pod. That's kind of the hard part. That's the part that's a little less virtual. That's the part where I touched a little bit with API. I really need to talk to devices. And that's where some of these projects, like support with the daylight and the projects, are actually starting to build infrastructures that allow us to explore, test these things. And OpenO, for those that aren't aware of it, is what we call a MANO project, management and orchestration. It solves the problem in a different way. It looks out the network, sees the capabilities that it has. You may have an SDN controller running the access, you may have an OpenStack system in the data center, you never talk to the top of both and sort of coordinate across the corridor. So it's a slightly different approach, whereas the ONOS project and the daylight projects go through a control plane approach, OpenO goes through a management plane approach, try and solve the same problem. Again, this is the OpenV loader. Again, OpenV plays a key role. OpenO is a management and orchestration system. It needs a platform to run against, and that's where OpenV provides that. Open Daylight and ONOS provide pieces of infrastructure that don't provide OpenStack, for instance. Looking forward to starting to package up a couple of scenarios. OpenV again is that full stack place where we bring all of this together, we do the integration, testing, and we check the endpoint extensions. And you can sort of ask, well, what's the point? This guy's been talking about this for ages. And it's a central office, it's in that building up the country, and I don't really care. Fair enough. What is the point? It's just a central office. The point is, it's a landing pad for us, the development community. It provides immediate access to ubiquitous compute. If I happen to have this type of virtual CO solution, then it's going to be faster for me to talk to the local data center than it probably used to be to talk to the print in the afternoon. The access to this type of computing virtualization environment changes dramatically when you directly connect into a data center, when you get access to assets from your provider. It provides workload flexibility and deployment flexibility. Let's say I'm running a central office, and let's say I have a autonomous car solution. Then if I have something like this VCO solution, and I have command control, I can set aside virtual network layers to access roadside units, for instance. Maybe you have a bunch of arms running on the roadside and traffic lights, measuring traffic, and so on and so forth. I should be able to deploy workloads to the dial service from my central office directly and have more or less a very flexible way of deploying the applications that I need to run. It's no longer I just run it in the cloud and I have latency issues going back and forth. I can pull workloads out where I need them. And essentially provides you with a data center in your house connected directly to IoT, for instance, where our house is going to be more connected. In this instance, I have, as I said, multiple connections from my house to a data center. The IT services, the IT services running that data center from my house to microseconds away. All of a sudden, the way we see, the way we work with the industry can drastically change this technology. What do operators get out of this? Why are operators pushing for it? Essentially, reduce complexity. I no longer need 400 different management systems. I no longer need 3,000 people to learn how to run them. We have to move to a consistent way of getting our access network going. So from an operator's perspective, they get to reduce the amount of technical competence they have to keep on board when it comes to managing and operating the network. If they want to run a new application, they're going to run their open stack. They don't need to know what's on the platform. They already know the platform. It's a very consistent experience for them. So, I guess the point that I really want to get here and talk about is there is a change in how we're doing access networking. It is going to be changing through VLT. Optics is going to change. How we're doing networking is going to change. But it all derives from these communities. It doesn't really matter which of these communities you're interested in. At the end of the day, you're going to have access to it. You're going to have more flexibility in how you work with it. You're going to have lower costs. I don't have to pay AT&T to sustain 3,000 to 4,000 people anymore. They may need 300 to 400, so they have to charge US and not US. That's all good. And it's all based on open source. Most of this is coming from open source communities, solving specific problems, feeding into a bigger picture. The open system, this is all good. This is where we get to play a role. We get to talk. And this is where these projects are more or less helping achieve the goals there. And I've got a little flashy science. I'm kind of out of time, which is good. I just wanted to come today and give you an overview, an introduction. We're going to hear from a number of projects today which are participating in the ecosystem, I guess. Maybe they don't think about those little office buildings and CEOs. Maybe they don't really care how time is terminated in the data center or how traffic is managed. But that all fits into this ecosystem in some way. So with that in mind, I will my presentation closed and open questions if anyone has any. I don't even have a microphone, so I don't need to repeat the question. Yeah.
So what about wisdom in the
In which aspect?
Well, it looks to me like you want to replace all these kind of switches as well by on top of this. Is that correct?
So at least in the central office, the OLT will be replaced more or less by software. So the OLT software will be there. As we do that for the network, we still have devices out there managing and terminating your OLTs on site and so on and so forth. But what's happening, I guess, in that domain is that you start to get people doing white box type solutions. Like here's the physical, like you run whatever software you like on top. And on the OLT side, you start to see people thinking, well, if I'm going to have a device terminating there and I'm going to be able to run workloads on it, well, I'm going to add some x86, or I'm going to add some processing to that. And that's where the real time, I think, fits in the best when I just start deploying it. Yeah.
I just take, so I'm happy to have more questions. Raymond? No? Yes. Okay, do you mind setting up our current Japanese practice and we can start on the new round for the half hour?
Yes, I have 5 minutes left.
Also, can we decompress it if you fragment please, we cannot have people in the steering wheel. Okay.
Bill, what's the shout question?